Okay, add and subtract mixed numbers, no regrouping, followed by add and subtract mixed numbers with regrouping. Let's give it a shot. So again, you can kind of sort of deal with the whole number and the fraction separately, so long as there's no what Khan Academy calls regrouping. Yeah? You can do this in any order you want. Just remember, you are doing 2 and 7/10 minus, and the important part is to remember that this minus applies both to the 1 and the 2/10, right? That is 1 and 2/10. Both the 1 and the 2/10 are being subtracted. So 2 minus 1 is 1, and 7/10 minus 2/10 is 5/10. So I guess this is what it meant when they said there would be no regrouping, right? The whole part is 1. The fraction part is 5/10. Our answer is 1 and 5/10. This works out perfectly so long as you don't go up above 10/10 or down below 0/10, because then you have to do regrouping, just like we did with regular ordinary addition and subtraction when we're talking about multiples of 10. 1 and 5/10 is the correct answer. Five and 1/3 plus 3 and 1/3. Well, 5 and 3 is 8, and 1/3 plus 1/3 is 2/3. No problem. 9 and 11/12 minus 2 and 8/12. Well, again, we'll take the whole parts, 9 minus 2, which equals 7. We'll do 11/12 minus 8/12. Let's see, 8, 9, 10, 11, so that gives us 3/12. Our final answer is 7 and 3/12. Again, when the numbers are nice and easy like this, you can just sort of combine like terms. For those of you who are coming up into algebra later on down the line, you're kind of combining like terms, right? You're combining the whole numbers with the whole numbers. You're combining the 12ths with the 12ths. You cannot directly combine the whole numbers and the 12ths without making a common denominator. It is really amazing how many of these patterns show up again later in algebra, and how many times it has seemed like you're looking at a brand new problem, a brand new type of thing, like combining like terms, when in reality, you've been doing it since 4th grade. 7 and 3/12. Seven and 4 is 11. 1/12 and 9/12 is 10/12. You will hear me using the word and rather than plus or minus a lot, because I really want to get used to the idea that plus and minus really mean the same thing. When I say 3 minus 4, that's the same thing as saying 3 and negative 4. If I say 2 minus 1, that's the same thing as saying 2 and negative 1. So you're going to hear me using that language a lot because I think it will be helpful overall. 7 and 6/10 minus 4 and 3/10. Well, 7 minus 4 is 3. 6/10 minus 3/10 is 3/10. Our answer is 3 and 3/10. Add. Once again, 6 plus 2 is 8. 1/4 plus 1/4 is 2/4. No problem. We're moving quickly now. Again, the whole number, 7 minus 1 is 6. 11/12 minus 6/12, 11, 10, 9, 8, 7, 6, 5. So it's 6 and 5/12. And that is adding and subtracting mixed numbers without regrouping. So now we're going to go ahead and do the exact same thing with regrouping. And I think I'm going to lump these two into one video. So same exact problem here. However, things get a little bit more complicated. Okay, I'm going to zoom in on this one. Things get just a teensy-weensy bit more complicated here. okay, we still get 6 minus 3 equals 3, right? We've got the two whole parts, and we've got 3. Fantastic, so far so good. The problem is, when we try to do 6 over 10 minus 7 over 10, we're stuck. We haven't actually learned about negative numbers yet here on our Khan Academy run. We can't do 6 minus 7. But just like when you are doing subtraction with normal numbers, normal non-fraction whole numbers, you can always, they say borrow, but you're really not borrowing. You're converting or regrouping, as it calls it here. Instead of 3, we can peel off that 1, right? We could call 3 2 plus 10 tenths, right? 10 over 10 is 1, so 3 is the same thing as 2 plus 10 over 10. And we can take that 10 over 10 and we can come to the rescue with it, essentially. And again, this is exactly the same as if I'm doing 27 minus 18, yeah? 7 minus 8 would be a negative number. We don't have that, so we take away 10 from the 20 and add it to the ones place to get 17 minus 8 is 9. Yeah? It's the exact same process. We are just peeling off a 1, making it into 10 over 10, and using that value so we don't end up getting something negative. Because again, we have not learned how to deal with negative numbers yet. That comes later. So we actually have 16 over 10 minus 7 over 10, which is 9 over 10. Check it yourself if you want. So our final answer is 2. Remember, we took 1 away from the 3 in order to make that fraction big enough to subtract. And 9 tenths. Nothing mysterious or arcane about this. It uses the same rules that we've been using this whole time. This is not anything new. The only new thing is the vocabulary. We're using tenths instead of using blocks or flowers or whatever. 2 and 9 tenths is the correct answer. Okay, here we've got 7 and 4/8 plus 2 and 7/8. So 7 plus 2 is 9. Not bad so far. We get 4 over 8 plus 7 over 8. Man, it's so nice when the denominators are already the same. It's going to get so much more irritating later on when we have to make the denominators equal, but for now, let's enjoy it, okay? 7, 8, 9, 10, 11 over 8. But 11 over 8 is a so-called improper fraction. If you put in 9 and 11/8, it's probably going to tell you to simplify a bit. Because it turns out 11 over 8, well, that's 8 over 8 and 3 over 8, right? 8, 9, 10, 11. And we already know that 8 over 8 is 1. We're going to be doing this a lot, friends. We are going to be recognizing that a number divided by itself is 1 a whole lot, like for the rest of math. It's going to be huge. It's how we reduce fractions. So 8 over 8 is actually 1. So we're going to take that 1, and instead of quote-unquote borrowing the 1 from the whole numbers place, we're going to give that 1 to the whole numbers place. Because that's another whole 1 that's going to be added in with the other whole 1s, right? Combining like terms, once we've got a whole number, it combines with the rest of the whole numbers to give us 10 and 3/8 as a final answer. Okay, 5 and 2/5 minus 3 and 4/5. I think we can already sort of see where we're going from here. 5 minus 3 is 2. 2/5 minus 4/5. Again, 2 minus 4 is too big, so we're going to peel a 1 away from this 2. and we're going to make it 5 over 5. Again, common denominator, right? We want the denominator to be the same. So we are essentially taking that 1 and adding it plus to this 2/5. So essentially what we're doing is instead of saying 5 and 2/5, we are calling this 4 and 7/5. These are the same. They are equivalent. We are just reorganizing them a little bit differently. We peeled off one of the whole numbers to add to that fraction so that that fraction is big enough to where we can do the subtraction without having to go into negative numbers. You could, by the way, do this if you know how negative numbers work. You could do this without regrouping, but again, that's something you learn down the line. So we actually get 7/5 minus 4/5, which is 3/5. Our final answer is 1 and 3/5. All right, last one. We've got 8 and 3/4 plus 5 and 2/4. So 8 plus 5, well, that's 13 if I'm counting right. 3/4 plus 2/4, well, that's 5/4, right? 3 plus 2 is 5. However, I know that I can pull 4/4 out of there and get 1 and 1/4. Now, I kind of skipped a step right there that I normally write down. So if you didn't understand how I got from 5/4 to 1 and 1/4, go ahead and back up to the beginning of the video and watch again, because I try to start taking away those scaffolding steps as I go in the hopes that you sort of understand the patterns and I can jump to the next step. But if it's ever confusing, if you're ever not sure what I did, you can always put a comment in the video with a timestamp asking, wait, how did you get that number? I will totally answer you. So we have 13 plus 1 and 1/4, which gives us 14 and 1/4. And that is adding and subtracting mixed numbers with regrouping. Moving on. So let's go ahead and do add and subtract mixed numbers word problems with like denominators. Again, that's a lot of words to say. We're just doing the same thing we just did, except there'll be some words involved. Let's go. Alicia hikes to see a waterfall. She records the weight of the items that she puts in her backpack in a table. Alicia's camera weighs 1 3/5 kg, stands for kilograms. A kilogram is about 2.25 pounds. Then her lunch. Record the weight of the camera on the table. So we're going to take her lunch, which is 2 1/5, and we're going to subtract the 1 3/5 of her, that it says that her camera weighs that much less, right? When it says it weighs that much less, we're doing subtraction. Again, code words. Okay, well, I can already see right now that 1/5 minus 3/5 is going to take us to a regrouping place. So I am, instead of saying 2 and 1/5, I'm going to change that into 1 6/5. Take a moment to see if you can understand what I just did there. It's the same thing we've been doing. I just peeled off 5/5, which is 1, took them out of the whole number 2, and put them into the fraction so that the fraction is now big enough to where it can subtract without going negative. 1 minus 1 is 0. 6/5 minus 3/5 is 3/5. Our final answer is 0 and 3/5, or just 3/5. All right, Archer made a tunnel for his hamster out of 2 cardboard tubes. One was 8 5/8 inches long. The other was 7 6/8 inches long. What was the total length of the tunnel? Total length means we are adding. So let's see. 8 plus 7 is 15. 5/8 and 6/8. Let's see. 6, 7, 8, 9, 10, 11/8. But again, I want you to see that I know that there is something I can pull out, that this fraction is bigger than 1 because the numerator is bigger than the denominator. If the numerator is bigger than the denominator, you've got at least one whole that you can pull out of that fraction and give to that 15. Yeah? So 11/8, well, let's see. 16 is too much, so that would be, instead of 15 over 8, I could call that 1 3/8. Yeah, if I take 8 of the 8ths out to make 1, then 11, 10, 9, 8, 7, 6, 5, 4, 3. I've got 3/8 left over. 15 and 1 is 16, so my total answer is 16 3/8. Again, I can see why this is so difficult for so many people, but again, try really hard to see the patterns here that make this the same as the kinds of problems that we've been solving for the last year and change, rather than something brand new that you've never seen before. 16 3/8. Nice. Amy collected insects in her backyard and recorded their lengths in a table. How much longer is the worm than the ant? So we're looking for the difference between the two, right? We're looking for the difference in their lengths. Difference in math usually means subtract. So it doesn't actually use the word difference here, but we are looking for the difference, right? We're looking for how different their lengths are. We are subtracting. So we're going to say that the worm is 8 8/10, and the ant is 5/10. Well, this is nice. We don't even have to regroup. Now, hold on for a second. Wait a second. What do I do with this 8? I'm confused. I don't know what to do. There is no common number there, right? There is no whole number that I can combine the 8 with. Well, technically there is. There is a 0 plus 5/10 there. We just don't write it because why would we? There is no number that we have to combine that 8 with. It just stays 8. Technically, it's 8 minus 0, right? The whole number in front of that 5/10, it is 0 5/10. 8 minus 0 is 8. But again, you don't even have to think of it that hard, right? Regular numbers combine with regular numbers. Fractions combine with fractions with the same denominator. I have 8/10. I'm taking away 5/10. That gives me 3/10. No need for regrouping at all. The answer is 8 3/10. Okay, Ava's birthday cake is 11 7/10 centimeters tall. Her candles stick up from the cake an additional 5 4/10 centimeters. So we want to know what the total height is. When we're looking for the total height, we are looking for a sum. We are adding them together. So 11 plus 5 is 16. So far, so good, I hope. Should probably move that a little bit lower. There we go. And then 7/10 plus 4/10 is 11/10. And I hope at this point we've been doing this long enough to where you can recognize that I can pull 10/10, which is 1, out of there with 1/10 left over. I can do 11 divided by 10, which gives me 1 with a remainder of 1, with a remainder of 1/10 left over. So my total is 16 and 1 is 17 and 1/10. And that is mixed number word problems. So far, so good. Like I said, things are going to start to get a little bit more complicated from here, especially once we have to start doing unlike denominators.